Hi guys, it's Tanto Fari, your mentor. I'm just going to do a basic introduction of the first project and just give you an overview of an understanding of what is required. I know a bunch of you, like majority of you guys, are already done with the project, but for those of you who are not done yet, I'm just going to give a basic explanation so you understand what's required of you. So the first project is all about predicting the price of diamonds, which a company intends to buy from a different company. And basically, this course is all about predicting the outcome of an event or understanding how to develop a model which will predict the outcome of an event. So in order for we to predict an outcome, we need to understand how to develop models that can predict outcomes. One of the ways which we can develop models is using a training data set to understand how the predictor variables are related to our outcome or our target variable. So many of you would ask, what is predictive models? Predictive models are used to predict the outcome of an event. So for example, say you're the manager of a business and you want to know how much revenue you would get for the year. Predictive analytics can help you develop a model which will help you understand what the revenue would be for the year. In order for you to do this, you need to have a training data set which contains your predictor variable and your outcome. So in this case, your predictor variable might be the number of goods that were demanded for a specific month, while your outcome would be the revenue that you generated for that month. So as I said earlier, your training data set is one of the data sets that would be needed for predictive analytics, and it has to contain a target variable and a predictor variable. The target variable and the predictor variable would help your model understand the relationship between both variables. And by so doing, you can use that model to predict on other data set. So one thing to keep in mind is the more the training data you have, the more chances of you improving the trained model. This doesn't always apply in it doesn't always apply, but it's a general statement in the sense that once you have more variables, it will help you understand how each variable relates to a specific outcome. Now, I mentioned that we had a training data set, but we also have a testing data set. So in a testing data set, the outcome is not known. In this case, the outcome is what we are trying to predict. But we also have the predictor variable because we need to know the predictor variable so that we would know what our outcome would be. So the trained model is applied to the test data set to predict the outcome of an event occurring. Again, in the case of you understanding what revenue you need for the next fiscal year or the revenue you're going to generate for the next fiscal year, you need to understand what was generated for the previous year. And at every point in time, say the month of January, February, or March, you need to understand that data. You need to have that data available so you understand what's expected or what's you're forecasting to get. So for most of you that haven't done the project, I'll just go through an overview of the project with you guys. Gives you an equation here, which is more like the equation of a straight line. So it's basically you're being provided with multiple regression equation for you to develop the price of diamond based on a specific data set. So you have the price of diamond in the past. So you already have something that's known, which is this data set. So based on this data set, need here. So all I'm going to do is, since the files, I've already downloaded the files, I'm just going to copy this equation here and I'll paste it in here. So it's an easy way for me to actually do this computation. So I'll delete this part, and then we know that the price is equal to this number multiplied by the carat, which is the weight. So I'm going to multiply it by the carat, which is this, plus 158.1 multiplied by the quart, which I'm going to do here, multiplied by the quart, which is this, because the quart right here is a categorical variable, but they've already changed it in this case to an ordinal variable. So assuming this equation is applicable, we can use this format. But when you go further in the lesson, you will learn how to convert categorical variables to dummy variables, which you can use to develop equations. So I'm just going to use this variable to multiply, this value to multiply the clarity, and I'll say equal to, so yes, and expand this a little bit, and I'm just going to double click on this just to generate the value for everything. So in here, in the Word document that was provided, they say according to the model, if a diamond is 1 carat heavier than another with the same cut, how much more should I expect to pay and why? So in this case, all you're doing is just looking at the price, and they're saying if the diamond is 1 carat heavier, so if you keep all the variables constant, so you keep the cut constant, you keep the clarity constant, how much more are you expecting to pay? This is basically an equation of a straight line. So what you can do is you can apply, say, 0 to the cut and 0 to the clarity, and then apply the variable 1 to the carat, and you'd notice that, let's just do it for an example. So for instance, let our cut be equal to 0, and then our clarity be equal to 0. So therefore, our price would be equal to negative 5,269 plus 8,413 multiplied by 1. So I said, for instance, let the cut be equal to 0 and the clarity be equal to 0. But also, I'm also saying let the carat, which is the weight, be equal to 1, right? So if all the variables are equal to 0 and the carat is equal to 1, we'll basically get that the price is equal to, I'll just bring up my calculator here so I can basically do the calculation. So it's going to be negative 5,269 plus, open bracket, 8,413 times 1 enter, and this will give us $3,144. Now, they say if the diamond is 1 carat heavier, so if we increase the weight by 1, so remember the weight previously was equal to 1. If we're increasing it by 1, that means the weight would be equal to 2. So increasing the weight by 1 would end up having the price would be equal to, so you're increasing the weight by 1 and you're keeping other variables constant. So price would be equal to 5269 plus 8413 times 2. And the price in this case would be equal to, I'll bring up my calculator again just to make sure you guys see what I'm doing. And in this case here, I'm just going to go back to this. Negative 5269 plus bracket open 8413 times 2. All this can also be done using Excel. So if you're doing this with Excel, it would be easier doing this because you already have the equation in Excel as opposed to punching the values in a calculator. So if I do that, I'm going to have 11557. Let's just confirm that's the number I have. So 11557. So the question is, according to the model, if a diamond is 1 carat heavier than another with the same cut, how much more should I expect to pay? So in this case, how much more? So how much more is calculating the variance between both price. So in this case, we'll have that our change in P, so change in P will be equal to P2 minus P1, where P2 is the weight at 2 carats, and P1 is P2 is the price at the weight of 2, and then P1 is the original case. So when you do this, you'll see that change in P would be equal to 11557 minus 3144, which would give you, if I'm to do this using a calculator, so I'm just going to say minus 3144 is going to give you 8413. And this value, if you notice here, this value is exactly the same as the value that we have as our multiplicator for the weight. So what we are saying in this sense is for every increase, for every 1 increase in the weight, or carat in this case, would have $8,413 increase in the price. Basically, you would notice from here that the price is directly proportional to our weight. So basically, using the model, you can just tell here what the new price would be, and you can develop the reason why you're getting the new price. Now, the second part of this question is saying, if you are interested in a 1.5 carat diamond with a very good cut, represented by a 3 in the model, and a VS2 clarity rating represented by a 5 in the model, how much would the model predict? How much would the model predict you should pay for it? So basically, this is just a simple step of you putting these values into the equation. So we already have the price equation. It's for you to put these values into the equation. And once you've done that, you will generate how much you would pay for it. So you put the weight variable here, and you put the cut variable here, and the clarity variable right here, and you get the price you pay for it. This part, the step 2 part, which is visualize the data, is saying plot the data for the diamonds in the database with character on the x-axis and the price on the y-axis. And you're doing this for the diamonds in the database, and you're doing this for the new diamonds that you expect to buy. So that's another easy ask, because what you can do is basically go to Excel. And again, the question is about plotting the weight on the X and the price on the Y. So that's just as easy as doing this, selecting the price, no, the weight, and then you select the price. Or you can just basically go insert and you go a scatter plot, this, right click, select data, add, and you can call it, basically you can call this diamond database, because there's the diamonds in the database. And then the X variable would be your weight. So I'm just going to select everything on the weight axis. And then the Y variable would be your price. So I'm going to select the price variable, and I'm going to hit enter and say okay. And I'm just going to scroll to the top, because I believe the chart is on the top. I'll give it a few minutes to get it loading. So there's the model that was the chart that was developed based on this data. And you can basically, if you're generating a chart or a plot, you need to help whoever is viewing the chart understand what's on the plot. So basically, you need to add the axis title, so both X and Y. So here, that's what I'm doing. So the axis title, so on the X-axis, we know it's the weight, which is character. And then on the Y-axis, we know it is the price variable. That's right there. So that's basically what we need for the second question. And then the first question rather. The second question is saying plot the data for the diamonds for which you're predicting the prices with character on the x-axis and predicted price on the y-axis. Note, you can plot both sets of data on the exact same chart. So if we are allowed to do that, then all you need to do is just select the data. So you go select again, and then you add, and you can call this predicted diamonds. You would want your terminologies to reflect what you're trying to have on the chart. That way, it's easily understood by anybody who is seeing it. On the x-axis, we can go to the new diamonds table, and we select the weight again. The y-axis, we go and we select the price, the predicted price, and we hit enter and okay. And okay once more. And you would notice that the charts on the scatter plot, this is basically a straight line. And if you take a look at the chart which was generated here, or the price of the diamond output equation which was generated is basically an equation of a straight line. So you would expect the chart that's generated to be a straight line. So in this case, all we need to do is we need to show the legend just so that we reflect that plot, what the legend is for each of the data. And then we need to add the chart title. So adding the chart title is just basically you telling people who are viewing it what is on the scatter plot that you're generating. So here you're going to do price versus weight, or price versus carat of diamonds. And once you're done with this, it's saying here that so once you're done with this, then you're done with the second question. The third question is, what strikes you about this comparison? After seeing this plot, do you feel confident in the model's ability to predict prices? I'll leave this part up to you for you to provide an answer. But basically, all you're doing is looking at the distribution on this plot and understanding why this model would be good enough, or if the model wouldn't be good enough. One thing I must point out is no matter what you're stating, you should remember to state that you have some outliers based on the data. So here we can see some outliers here that's existing on the chart. So don't forget to mention this in your submission template. Just mention that you have some outliers, and I'll leave it for you to generate the statement that you want to generate, or you need to generate. Then the last part is make a recommendation. So what price do you recommend the jewelry company to bid? What price do you recommend the jewelry company to bid? Please explain how you arrive at that number. So again, you have we've used the model to actually generate or the equation of a straight line to actually generate these prices. And one of the things you can do is you can look at the 5-number summary. I know this is slightly out of the scope of this course, but one of the things you can do is you can look at the distribution of the price. So to do that, you can do that on a histogram. So here's a histogram, or you can do that on a box plot. A box plot is actually a better plot to actually see the distribution, because it's going to give you the 5-number summary easily. So in here, you can tell how the data is distributed, whether it is skewed to the right, whether it's skewed to the left, where the median is. So here we see we have the maximum, we have the minimum, we have the third quartile, the first quartile, we have the median, and we have the mean. So based on this, you can tell where if this model is actually good enough for you to generate what should be used for the bidding. And you should also keep in mind the company generally purchases diamonds from distributors at 70% of that price. So you should account for the 70%, because there is no company that would want to buy at a loss. Every company would want to buy at them making some form of profit. So you would want to account for the 70% in your recommendation. Good luck with the first project, and if you have any questions, always feel free to send me a message on Slack, and I'll always be glad to assist.